Once you have split the faces and you want to run the analysis, you can either run the analysis on Autodesk Inventor or in Nastran. So for the time being, I'm running an analysis on Autodesk Nastran because it ran an analysis quicker for me earlier on. And I can even edit the study I already have, or I can create a new study. For the time being, let's say for the sake of discussion, if in order to be on the safe side, I will just delete this, or I will just create a new study. You can duplicate it if you want to keep your results safe, but for the time being I do not need it, so I've just deleted. I'm going to start from the scratch so that everyone can start from the same level. I will delete all the idealizations I have so that I'm starting from scratch. I will make sure I don't have any load specified. I will make sure I don't have any constraints specified already. I'll just delete those. Once you have done that, the next step is again click on structural members, convert everything into structural members, and you will be able to see the solids. The next step is to ensure that every component you need is there, and whatever the component you don't need, you can exclude that from study. The next thing is to add the idealization. As in our previous analysis, when we ran the analysis, we were not able to mesh on the top plate, so we can just manually add top plate and assign the material mild steel. Press OK, and the material will be assigned. The next step is to add constraints. Select the bottom face. That's OK, and your constraints will appear. Okay, the next step is to apply the loading. We cannot apply force load. We cannot apply distributed loading because the components we have is not a 1D element. So distributed loading can only be applied on 1D element. If you put any random number and you press OK, the distributed loading will not be applied. As you can see, the distributed loading is not being applied appropriately. We cannot apply the distributed loading on the faces. We have to select the edges to apply the distributed loading. So in this case, we'll just delete this load. Ensure you delete it from the model tree and ensure that the arrow for the load is fully disappeared. Okay, now specify the loading. If uniformly distributed load is given to you, you can just multiply it with the surface area and or the length to find out how much is the total load. For example, if 30 kilonewton per meter is given to you, so you can just multiply 30 with the height of 30 and that will give you the overall loading. In this case, let's say the loading which is given to us, for an example, I'm just putting a random loading and I want this to be 25,000 newtons to represent 2.5 tons of loading. I'll just select the middle surface and I'll press OK, and the loading will be applied on the middle surface only. Now, as I have split the edges already, I can apply the loading on the vertical beams as well. Select loads. We cannot select the distributed loading. As I have mentioned earlier, distributed loading is only applicable to edges or sketches. It's 1D element. It's applicable to 1D element. But for the time being, we can apply the force. If the loading is given to you as 30 kilonewton per meter, and the total height at which you want to apply the loading is 30 meters, you can just multiply 30 kilonewton per meter by 30 meters, and you will be remaining with 900,000 of loading, water wave loading, 900,000 newtons of water wave loading. So in order to apply that loading, you want to apply in the components, and once you select the face, you will be able to see the coordinates. And the loading is, if you want to apply loading in this direction, in z-axis, so you just enter the value 900,000 minus 900,000 newtons of loading in z-axis. Select the beams you want to apply the loading on. Okay, so the water wave loading will be affecting these beams most. So press OK. Minus 900 is facing the opposite way, so we can just remove the minus sign. Double click on it to remove the minus sign. And now this is the true representation of water wave loading on the jacket structure. Once the water wave loading is being applied, your loading on the top plate is being applied, you can specify the automatic contacts. Once your contacts are done, the next step is to specify the mesh settings. Refine the mesh as much as you can. Change the element order to linear to quickly run analysis, continuous meshing, and press OK. The meshing will start developing, and wait for it to complete. Once the meshing is completed, the next step is to just run the analysis. Wait for the analysis to complete, and you will be able to view your results in a few minutes. It took around 2-3 minutes for the analysis to complete. Press OK, and you will be able to view your results. Initially, you will see exaggerated results and exaggerated deformation. You may have to turn it off to see the actual deformation. Let's click on Options. Deformation options, click on Actual. And you will be able to see the actual deformation. Press OK. And as you can see, the stress which has developed in the material is around 794 megapascals, which is quite a lot. And you need to analyze whether the structure is safe under the water wave loading and the loading you're applying on the top plate. You will be able to see the maximum stress which is being developed is at the bottom of the beam, bottom of the jacket structure where it is fixed. You can view the results in terms of displacement. Click on Options. And filter data, change it to displacement, and you will be able to view the maximum and minimum displacement. So analyze the jacket structure in this way, and that's how you run an analysis for the water wave loading on Autodesk Inventor. Next, and then a maximum deformation will be around 320 millimeters. So analyze this behavior of the jacket structure. You will be able to find some structural issues, and you may want to resolve the structural issues and see whether they are catastrophic or not. That's